So thank you, Ron. Good morning or afternoon. I'm Yang Chen, the Director of Overseas Business Development at Microquanta Semiconductor. It's a real pleasure here to be today, and I'm honored to share with you the exciting work we have been doing at Microquanta. So let's dive in. Let me begin with a quick journey through time, our story, which is also the story of Perovskite technology breaking into the real world. Microquanta was founded in 2015 by two device physicists, Dr. Jizhong Yao and Dr. Bu Yiyan. At the time, perovskite solar cells are still just a lab curiosity, but our founders saw something more, not just a promising material, but a paradigm shift in solar technology. In 2017, efficiency for certified by Newport PV Lab in Montana. This marked the first global benchmark by a Chinese perovskite company, and the first of many. To date, we have set 12 world records in perovskite module efficiency. By 2020, we broke ground in Quzhou on the world's first large-scale perovskite production base, 100 megawatt capacity, built for true industrial scalability. In May 2022, we launched the Alpha series, the world's largest commercial perovskite modules, designed for utility-scale use and backed up by a 25-year warranty. And in November 2024, our Alpha Tandem modules were delivered to a 500 kilowatt pilot project with China's Three Gorges Corporation. The project now is under construction. Last year, we achieved 13.74 megawatts in sales, securing the number one market we secured the number one market share in the sector. So in less than 1 decade, we have grown from a lab startup to a global player, shaping the future of solar, and this is only the beginning. Our breakthroughs aren't just a record, they are real-world enablers for the next generation of solar. Let's talk about what sets our technology apart. First, reliability. Our module comes with a 25-year linear power warranty and a 12-year product warranty. Degradation is under 2% in the first year, and just 0.7% annually after that, ensuring decades of stable output. Our second generation module, the Alpha Square, had passed the updated IEC 61215 and IEC 61730 test from the International Electrotechnical Committee, earning full certification of stability. Last year, we also passed the IEC TS 63209 series, which adds extra environmental stress tests. This put our Alpha Square module on par with the highest durability standards in traditional solar technology. Second, the low light performance. Perovskite has a unique advantage. It performs exceptionally well in diffuse light, like on cloudy days, on shaded roofs, or on dense urban environment. Third, minimize hotspot effect. Our whole surface by-contact design reduces the risk and improves the lifespan. And the advantages don't stop there. Next is microcrack resilience. Unlike silicon, our perovskite layers are more forgiving, less prone to power loss from handling or environmental stress. And then the temperature coefficient. In hot weather like Zhejiang summers, where temperature can often approaching 40 degrees Celsius or 104 Fahrenheit, our module can produce up to 30% more energy than traditional solar panels. That's because silicon solar cells lose a lot of efficiency when temperatures rise. And finally, our quantum dot color conversion layer. It transforms UV and infrared light into visible light, enabling vibrant, tunable BIPV modules without sacrificing much energy output. In short, we are not just building solar panels. We are building a smarter, stronger, and more versatile solar platforms. And now to the big question, can perovskite truly survive outside the lab? We have put our modules through real-world tests in some of the most demanding environments. In Zhejiang, we developed a 259 kilowatt system above an aquaculture pond, where constant moisture and evaporation are a challenge. With advanced encapsulation technology to block water and oxygen ingress, the system now operates stably while supporting local economy. We've also tested our modules side by side with crystalline silicon across multiple climates. In Kubuchi Desert, a 1 megawatt plant operates under intense radiation and wild temperature swings. Results show that our perovskite system generates 6% more electricity than bifacial silicon and 17% more than monofacial silicon. In Wenchang, Hainan, we tested our alpha module in a hot, humid, typhoon-prone climate, which is ideal for evaluating extreme environmental durability. Our modules were among the first to join the test program, and the results speak for themselves. Performance ratio exceed 1.0, far above the 0.85 benchmark for crystalline silicon. On overcast days, the PR value can reach up to 1.16. These results highlight the superior low light performance and optimized temperature coefficient of our modules. In humid, cloudy, and high temperature environment, they are clearly outperform the traditional silicon. And back in Quzhou, where our manufacturing base is, we run a real-time demonstration site with publicly available performance data. Here's a quick snapshot. In just one typical week, our perovskite modules produce 30% more electricity than crystalline silicon under the exact same insolation conditions. If you have interest in tracking this data, please come talk to me after the session. I will be happy to add you to our weekly newsletter, where we shared all this data in real time. So from desert to coastlines, our modules are proving their reliability and resilience every day. Let's take a closer look at how our technology performs on ground. In Hangzhou, we installed a 150 kilowatt ground mount system at Yinlingguan Expressway, themed Poetic Zhejiang. The custom printed green and white modules blend into the landscape while delivering 3.74 million kilowatt hours annually, which means cutting 1,300 tons of standard coal and 3,500 tons of carbon dioxide. Next up is Quzhou High-Speed Railway Station. Here we installed a 444 kilowatt rooftop BIPV system using light gray modules that match the building's architecture. It shows how perovskite can be more than just energy hardware. It can be a true architectural material. And then in Shanxi Shenchi County, we delivered an 18 kilowatt semi-transparent skylight for a university innovation hub. With 40% less transmittance, it brings in natural daylight while generating clean electricity, even under tough structural and weatherproofing requirements. All of these three formats, color, facade, and transparency, showing that perovskite can power not only the grid, but the future of urban designs. So what's next after the proven performance, even higher performance? Let me introduce our Alpha Tandem module, now certified at 25.4% efficiency. Its 1200 by 600 millimeter module features perovskite layers on top count cells, bringing together the two high-performance technologies. What worth to mention here is a four-terminal architecture. The perovskite and silicon layers are manufactured independently, avoiding thermal mismatch and current balancing issues. This makes it easy to integrate with existing silicon lines, a true plug-and-play upgrade for the manufacturers. With precise spectral matching and an innovative transparent electrode design, we are extracting maximum power from every photon. This isn't just a record, it's a scalable pathway to the next generation of photovoltaics. We have talked about where we are, now let's look ahead. Our 1 gigawatt factory in Quzhou is on track to begin production later this year, marking the start of the industrial scale perovskite manufacturing. With this facility, we will launch larger format modules. The upgraded Alpha series will reach 460 watts, and the Alpha Tandem series will reach 660 watts. Both are using a 2400 by 1200 millimeter format, which means lower system cost, faster installation, higher energy yield, all without compromising durability, thanks to our step-by-step industrial progress. From our 20 megawatt test line to 100 megawatt base, and now the 1 gigawatt factory. We have built the know-how and the infrastructure to support the consistent quality and long-term performance. And on cost, with vertical integration and scaled production, we are approaching the price parity with silicon and well-positioned to surpass it. At Microquanta, we are not just improving solar, we are preparing it for mass deployment, for smart infrastructure, and for a cleaner and more sustainable world. That's it. Thank you.
Thank you. Thank you, and this was really interesting and right on time, very quick. So again, very impressive. We have some questions from the audience. First of all, before, can you tell us a little bit about the potential flexibility of your perovskite solution? We know you showed some tandem panels, but do you see the possibility of doing flexible panels?
We are definitely, they are actually like our research pipeline. And what I can tell you right now is we are developing curved panels. And the stability and the durability is still on test, but we should have the data released pretty soon. Our progress is good. It actually depends on the thickness of the glass. So if you want to go like a little bit thinner, I think the curves can be a little bit better. But currently we are looking at the radius is about like 65.
Interesting. Okay, thank you. Can you talk a little bit about the toxicity problems? We know that perovskite suffer from, the inclusion of lead, the lead material inside. What is Microquanta's view on that?
Sure. So actually, this is a very common concern from everybody. So the lead concern in perovskite is very minimal because the raw material we are using in these solar cells are like 50% less than silicon solar cells. So which led to that the lead content in our panels are very minimal and way below the limit, the regulatory limits in EU. So we are lower than that. And also it's well encapsulated between the glass stacks and with the sealant. So we have, from the field data, we have no leakage accident before. And at Microquanta, we are actually active developing the lead-free process. And also we are developing the recycling program as well.
Interesting. Great. And maybe a last question about cost parity with silicon. We're talking about tandem panels. So how do you see the gap in cost when adding the perovskite layer? When will it make sense for the market, to adopt these panels like in mass production? What will be the cost point?
We're really looking forward to our production by the end of this year from our 1 gigawatt factory. At that point, we are looking forward to have a really parity price ratio with silicon. Maybe in the future, maybe a little bit lower.
But for tandem panels, is that possible? Or
for tandem panels, what I will say right now is we will be like 2 to 3% efficiency higher than silicon solar panels, but our price will be also a little bit higher, but not much.
Got it.
Maybe 2 to 3 cents per watt, a little bit higher than that.
Impressive. So that makes sense commercially. So good. Yes. We'll be looking forward to hearing you in October in Berlin in our event on site. And everyone, again, that wants to talk to Ryan, you see her email here in the slides, and you can meet in the speaker room after the end of this session.